Good morning everyone. Today we are continuing with the topic salts. In the previous video we discussed about sodium hydroxide, then bleaching powder and washing soda. Today we are going to learn about baking soda, plaster of Paris, and then what is water of crystallization. Now this baking soda or NaHCO3, its formula is NaHCO3, also known as sodium bicarbonate or sodium hydrogen carbonate. This is its chemical name. Common name is baking soda. Chemical name is sodium hydrogen carbonate, or we can also call it as sodium bicarbonate. Now, how it is prepared? Again, as I told you before also, the raw material for its preparation is NaCl, that is sodium chloride, right? So we take a cold, concentrated, aqueous solution of NaCl, which is known as brine, right? And we pass ammonia and carbon dioxide, or we react it with NH3 and CO2, ammonia and carbon dioxide, and as a result we get NaHCO3, that is baking soda plus ammonium chloride, right? Now when we heat this sodium hydrogen carbonate, on heating we get sodium carbonate plus carbon dioxide. Now because it is a carbonate, as I told you before also, whenever we heat any carbonate, always carbon dioxide gas plus water is released. So here also we get Na2CO3, that is sodium carbonate, plus carbon dioxide plus water, right? Now this sodium hydrogen carbonate, it is a mild corrosive base, right? So, because it is a mild base, it is also used as an antacid. Now, what are antacids? The substances which are used to neutralize the effect of acid. Sometimes the quantity of acid increases in our stomach, and for that we use any antacid so that it will neutralize the effect. Any base, any mild base we use so that it will neutralize the effect of acid. So here this baking soda is also used as an antacid. Next, it is also used for making baking powder. Right? Now, what is baking powder? See here, this NaHCO3, right? It is mixed with any, now baking powder, it is a mixture of any very mild acid, right? So any like tartaric acid, right? Tartaric acid plus this sodium hydrogen carbonate. So any acid, tartaric acid, of course it has got a very long formula. So any acid, it has got H ions in it. So we are writing only H ion here. So this sodium hydrogen carbonate, when it will combine with any mild acid like tartaric acid, it will again release carbon dioxide and water. Now this carbon dioxide gas which is released, it is used to make the dough very soft and spongy. That is why we use baking powder in if anything we have to bake, we have to make cake, biscuits, etc. We put it in the dough. Now we cannot use only baking soda because that will give it a little bit bitter taste, because it is basic in nature, right? Now when we mix baking powder also in it, what will happen, this baking powder, it has a mixture of baking soda plus any mild acid. So when it will come in contact with water, this will release carbon dioxide gas. Now here see, both are present, but in the powder form they will not react, they will not neutralize each other. Right? When they are present in the powder form, they will, otherwise this is a base and this is an acid, they will neutralize each other. No, in the powder form, they will not neutralize each other's effect. But when they are put in the dough and mixed with water, what will happen? Whenever it will be mixed with water, then it will release carbon dioxide gas. It will neutralize the effect and it will release carbon dioxide. This carbon dioxide, it will help in aerating the dough. And when we will heat it, when we are baking anything, what will happen? This carbon dioxide which is trapped inside the dough, this will start coming out in the form of bubbles. Right? And that will make the whatever thing we are baking, whether it is cake or biscuit or anything, it will make it soft as well as spongy. It will help in raising the dough up. Right? So this is how it works. The baking soda and the baking powder. So we should not use only baking soda when we are baking anything. That will give it a little bitter taste, but when we add baking powder to it, it will neutralize its effect. Right? And it will give it a good taste. Then next, it is also used in the fire extinguishers. In fire extinguishers, what happens? This sodium hydrogen carbonate, it is made to mix with H2SO4. Suppose this is a fire extinguisher bottle, right? And right, so here in this bottle, this NaHCO3 is put. That is sodium hydrogen carbonate. And in this, a bottle, either it is, we can hang it like this, right? A bottle in which H2SO4 is put. Either we do it this way, or here also a bottle can be put having H2SO4, right? Either this way or that way. Here the bottle is put. So what happens? When this knob, during time of emergency, this knob is hammered, it is pulled down, this bottle will break. Right? When this bottle will break, or here what this fire extinguisher bottle, it is swirled. So what will happen? This sulfuric acid will come out and react with NaHCO3. So NaHCO3 plus H2SO4, when they combine together, because this is a carbonate, it will release carbon dioxide and water. This carbon dioxide gas, it will come out of the nozzle. There is a nozzle here, right? And it will come out through this nozzle, and we can put it on the fire. It will make a blanket over that fire. You know, carbon dioxide, it is a non-supporter of combustion. Right? So it will cut off the supply of fire, right? And it will extinguish the fire. It will cut off all the supply of oxygen, whichever is available there. It will form a type of blanket over the fire, and the fire will be put off. Right? Next salt is plaster of Paris, commonly known as POP. This is known as POP in the common language. Plaster of Paris. Now this plaster of Paris, its formula is CaSO4 half H2O, or calcium, chemical name is calcium sulfate hemihydrate. Because this is just half the molecule, so it is known as hemihydrate. And this is prepared from gypsum. Now why it is is known as plaster of Paris because it is made from gypsum which was initially found in Paris. That is why it was named as plaster of Paris. Now this gypsum, which is CaSO4.2H2O, that is calcium sulfate dihydrate. This CaSO4.2H2O or gypsum, it is heated at 100 degrees Celsius or 373 Kelvin to produce POP, that is CaSO4.2H2O plus 1.5 molecule of water is released. This has to be heated at 100 degrees Celsius only in a controlled manner. The temperature should not increase, because if the temperature increases, then it becomes a dark black colored solid mass which is of no use. Right? Then it becomes black dry plaster. So that is why it is important that it should be heated only at 100 degrees Celsius in a controlled manner. This is a question also, important question, that what is the temperature required or why it should not go beyond this, why the temperature should not go beyond this. This can be asked in exam also. So remember this, that gypsum, when it is heated at 100 degrees Celsius, it will change to plaster of Paris. Now why this half molecule of water? Half molecule of water, otherwise it is it cannot be written like this. Why it is written as half H2O? Because actual formula for plaster of Paris is 2CaSO4.H2O. This is the actual formula of plaster of Paris. That is 2 molecules of calcium sulfate. They contain 1 molecule of water of crystallization. Right? 2 molecules of calcium sulfate, they contain 1 molecule of water. So here, because we are just writing 1 molecule of CaSO4, so that means it will just be half molecule of water. 2 molecules of calcium sulfate contain 1 molecule of water. So 1 molecule will just contain half molecule of water. So we can also write this equation as CaSO4.2H2O, that is gypsum, on heating at 100 degrees Celsius produces 2 CaSO4.H2O plus 3 molecules of water. We can write it in both the ways. Right? Now, next, you know the uses of plaster of Paris. Plaster of Paris can be used to make toys. It is also used in hospitals to set the fractured bones. You must have seen if someone gets the bone fractured, a white color plaster is put over it. That is also plaster of Paris, because after setting it becomes hard solid mass. Right? So whenever water is mixed in it, for half an hour it remains, it takes to set completely. So it is used for making toys, it is used for making ceilings, decorative ceilings, the decoration of the pillars also, used for making statues, right? So these are some of the uses of POP, plaster of Paris. Now we have been talking about water of crystallization when we studied about washing soda. That time also we learned about that washing soda also contains 0.10 H2O water molecules. Here just now we have studied half H2O or 2 H2O. This is water of crystallization. So what actually is water of crystallization? It is the fixed number of water molecules present in one formula unit of a salt. Right? In any one formula unit of a salt, this is fixed number. Like here we are talking about 0.5 H2O or 0.2 H2O, or for washing soda we learned 0.10 H2O. This number of fixed number of water molecules present in one formula unit, that is known as water of crystallization. Here I've written some examples also, like copper sulfate, CuSO4.5H2O. So it will be known as copper sulfate pentahydrate. 5 molecules are present, so it becomes pentahydrate. Here it is Na2CO3 washing soda 0.10H2O, that is decahydrate. Then FeSO4.7H2O, that is ferrous sulfate heptahydrate, or CaSO4.2H2O, that is dihydrate. Now what happens is, when these are heated, any of this salt, when it is heated, it loses its water of crystallization and become anhydrous. The other day also I told you about anhydrous salts, right? Anhydrous means, now this water of crystallization, this gives the shape, crystal shape, right? And also give color to that substance. Like CuSO4.5H2O, this is blue in color. This is of course white in color. FeSO4.7H2O, this is green in color. Then calcium sulfate, this is also white in color. So it provides color also to these crystals and the shape, right? But when this these salts, they are heated, the water evaporates and it becomes anhydrous, that is in the powder form, and loses its color. Like when we heat copper sulfate, the CuSO4.5H2O, it will lose its blue color and it will lose its crystal. This is in the crystal form. But when the water evaporates, it becomes a white color powder. It will lose its color, it will lose its shape. But again, when we put water in it, again it will regain its shape also and color also. So these salts which have water of crystallization in it, when we heat, it will lose its water of crystallization and lose its color also and shape also, but they can be regained back on adding water to it, right? So this is all in this chapter. We have finished this chapter. If you have any queries, you can write in the comment box. I'll try to solve your queries. And next now, we'll start with the other lesson. Thank you.